What if the future of electric vehicles depends not just on making better batteries, but on finally being able to see what is happening inside them before failure, waste, or fire ever occurs? Welcome to Industry Ignited. I'm Dr. Leeanne Aguilar, and today I'm joined by Efrat Avnet Steinberg, CEO and co-founder of Inner, a company developing breakthrough CT technology to detect microscopic faults inside EV battery packs and modules. Efrat, welcome to the show.
Hi, thank you for having me, Leanne.
Yes. So tell me, your career has moved from law to business development, product development, innovation, and now deep tech entrepreneurship. What has connected all those chapters for you?
Wow, what a question. I think first and foremost, you need to be a really curious person. I think that really is common to all of the things that I've done. You need to constantly learn new things and really be passionate and love learning new things. I think it's also, you need to be analytical. There's a lot of information, there's a lot of data, and you need to really be able to quickly discover what is important, really be able to focus on that. I think what I always found out is that I really love technology. I'm not a technological person, as you said. My education to begin with was legal, but I really love learning from technological experts and be able to translate the technological story, into a verbal story, and to be able to communicate it to the other partners. I think what I also found always common is loving people and loving building relationships and building a group of people to really do amazing things together.
Right. Yeah. So do you feel like your law background benefits your business these days and how you communicate, how you tell stories?
I think so, definitely. The ability to analyze a story, a text, a situation, and to really focus on what's the essence of it, what's the core of it. And I think this is something that I use every day now.
Okay, interesting. Yeah. Now, you've said that you are drawn to beginnings, clean slates, and building something from an idea. When did you first realize that creating new ventures was where you thrived the most?
I think it started when I was still working in a corporate. I was given a task of starting a new project really from the beginning. And it was really a non-core project. It was a big telecommunication group. But the project that I was given was really, it's hard now to imagine a world without it, but it was a mobile wallet. Talking almost 20 years ago, so nobody was even close to having it. And the idea was really thinking of what was the best, could we do it, and what was the best concept for us. And we started building a group of people around us, and I fell in love with this concept of convincing people to stay away for a minute from their recurring core job and actually making them fall in love with something completely new. And that was really against all odds. So I actually fell in love with it, and building a huge group of people around me with a lot of passion and a lot of drive to build something new. That was the first time where I felt that actually building something from scratch was so much more interesting than just running an ongoing business as somebody else formatted.
Right.
And later on, when I started working with startups as a consultant, I discovered that that's what startups do. And I just naturally found my way into the startup world.
So out of curiosity, because I know people are in general are resistant to change. And not only that, like getting first adopters, to try out a new technology is often a big challenge. So how did you approach that? How did you overcome that?
I think it's first listening. You need to really learn what the other party, whether it's a business partner or a colleague or just any kind of stakeholder that you're trying to engage, what is their interest? What is their need? Is there a problem that they're trying to solve for themselves that by collaborating with you, it's getting solved? So I think it's really listening, talking to people, understanding what they need is really the best strategy. And oftentimes the interests align. So I think that's usually the best strategy that worked for me.
Yeah, right. So finding out how your interests align and then really listening and finding out what they're experiencing and how to help them overcome their issues, perhaps with the new technology. Okay. And see how or letting them know how it benefits them. And,
exactly.
Identifying those advantages.
Exactly.
Yeah. So you mentioned that you work for a large telecom company. How did your experience in telecom, corporate innovation, and city-level economic development prepare you for leading a highly technical battery imaging startup?
Yeah. So it's being able, again, to learn, to deep dive and learn very, very quickly to new technologies. So although the previous companies were not directly involved in imaging, in my case, but they were advanced software companies, very complex business settings. So the ability to build partnerships there, to really understand the technology and know how to work closely with technological people, really built the right background for that. When I joined forces with my co-founders that are imaging and diagnostics experts, come from technology, combining forces together built what is really the strong founding team that we have, because we are combining this general background of different perspectives into technology and business with the domain expertise of imaging and diagnostics. And this together is exactly the complete picture that is needed to get our business going.
What was it specifically about this technology and this problem that made you say, I'm not just advising on this, I want to build the company around it?
Yeah, I think the ability or the opportunity here to really make an impact. We found a problem that nobody was able to solve, and we see it because the quality problem in batteries is really clear. The industry experiences that. You see it when you look at the warranty reserves and the warranty claims that are over 100 billion of warranty reserves, which is crazy. This immediately impacts all of our pockets when we're buying a vehicle today. So the moment we learned about this problem, it was the opportunity to actually make an impact and solve this problem that was so attractive and so irresistible, I think, to us.
And so for listeners who may not realize how big this issue is, tell us more about what is happening inside EV battery packs today that traditional quality checks are missing.
Yeah. So of course, a battery is a complex object that goes through mechanical, electrical, and chemical processes the moment it hits the road. And those processes are causing degradation and a lot of problems that a better structuring of the battery, a better formation of the battery is going to limit. Of course, you can never really stop. The battery will deteriorate and the performance will deteriorate over time, but we can really delay this process and make sure that at least the first few years is going to be a very highly performing battery. And today testing at the production line are failing to see if there's already a mechanical problem, physical change, if it does not impact the performance. So the abuse test and the electrical tests that are done on the production line are not necessarily going to catch it. And when you talk to the industry, they talk of over 2%, and some of them are even talking about 5% of batteries that are sold to the public with a problem from day one, which is quite insane. Yeah. And this, of course, as we said, impact the performance. And if I can give you an example, and we are talking about the assembly process of battery cells into battery modules and packs. So if we're talking about the phenomena of a loose wire, for instance, if we have a wire that's been welded between the cells and it's a little bit loose, if you test it electrically, it will pass the test. But once the battery is assembled into a car, now the car drives on the road for miles and miles. It hits bumps in the road, and a lot of mechanical pressure is of course impacted. And then the wire might get loose, and then performance is affected. But that's too late, right? Because we're not testing the battery for that at the moment. And then you will see phenomena like recalls that are over 100,000 batteries every year across all brands. And you see a lot of other types of failures that are not a reason for a recall. But still, warranty, as we said, warranty is impacted. The OEM is now collecting the battery from the customer. The customer is issued with a new battery. And this is, of course, is a very high cost. So traditionally, every OEM would reserve around between 600 and 700 battery on their books to make sure they're prepared to take care of that phenomena. When EVs are coming, and you see over time for an EV, they would put aside between 1,000 and 2,000 already. So we're seeing a growth in those funds that are reserved, and a growth in the claims that are paid to customers. And this is exactly the type of problem that we tackle, that we want to help the industry face.
Yeah, very expensive problem, I'm hearing. And not only that, but inconvenient for the customer and even a safety, issue.
Of course.
Right. So why is it so difficult to detect microscopic faults, swelling, cracks, or, like you mentioned, faulty wiring inside assembled battery
Yeah.
modules and packs using current methods?
So, as I said, the electrical methods many times do not catch those phenomena on the production line. And the best way to really look inside matter has been always good old-fashioned X-ray. And then what was the problem is that it takes a long time to really, because you're trying to scan through an object which is quite big. Battery module, I don't know if people are, I'm trying to see how I can demonstrate that. But a battery pack is really the size of a car, right? It's really holding the chassis of the vehicle. So we're talking about a very big one. A battery module would be, you would have in a battery pack, or it depends, but let's say 10, 12 modules are building the pack. So it's a very big object. And to penetrate through such a module, looking for things that are 100 micron, 200 micron, it means a lot of data. Usually, traditionally, scanners that are existing in the industry would take a long time. So none of them would be part of the production line. You would use them for lab research or for sampling from time to time, or to investigate after you already know that there's a problem. And nobody was really offering something that would do it at the production pace. Therefore, you would miss those problems, because if you do sampling for something that's already existing in 5% of the modules, your chances of catching it are very, very slim. In order to catch something with that type of existence, then you need to really scan every single one. And that was the challenge that we are solving, because we built our own solution to be the perfect optimization between image quality and the production pace. We will never slow, of course, a production line down, because then nobody would use us. We understand it. We need to accommodate the needs of the OEM. And that's exactly our strategy, optimizing image quality with the production pace.
Okay, great. And like you mentioned, Inner focuses on modules and packs rather than cells. So why is that distinction so important? And where do you see the biggest quality gap in the market?
Both exist. There is an issue, of course, with cell analysis as well. There are companies that specialize on that. We found the challenge of pack assembly and module assembly much more interesting for us, because we had expertise in analyzing large amounts of data very, very quickly and solving that part was the most interesting for us. At the same time, we collaborate also with other companies that focus on cell analysis, and who knows what will be the future. There are interesting collaborations on the table already, but most of those companies are unable to do module and pack analysis. So we felt that was the place for us to shine and bring value where others are struggling.
So Inner is building a CT scanner capable of inspecting large battery systems in real time on the production floor. What makes that technology possible now when it hasn't been before?
Yeah. So the largest challenge, first of all, was to be able to do fast computing, fast processing, and image processing very, very quickly, again, to fit the production line pace. For this, we developed our own proprietary technology, and that's what allows us to introduce this solution. It's also interesting to mention and to highlight that usually, of course, to build a new machine learning based solution, you need to have a lot of data. And what is unique here is that the data that's available in the world today is cell-based data. And the access to information, to data that analyzes modules and packs is very, very low. So we had to develop our technology based on the data that was available, and to produce our own data and to generate our own data to be able to make progress and to do diagnostics. And we have done that by introducing a service offering. That's what was really what we were busy with in the last couple of years. So to collaborate with OEMs around batteries that are failing already with them, and to do those service offering. And we actually do it with our partners at Fraunhofer in Germany, where we do scans using their equipment and doing our own analysis. this allowed us to see a lot of phenomena that usually is not available, that this data is usually not available. So we learned a lot from that and collected data. Yeah.
So you're found a new way to collect data that hadn't been previously collected.
To bridge the gap.
That makes sense. So you're combining imaging, software, and data processing at industrial speed and scale. What has been the biggest technical hurdle in making that commercially viable?
I think it's basically the lack of data, as I mentioned. The lack of data was really a challenge. But as I said, we've been creative. You have to be. As a startup, you always need to be creative in bridging the gap, in finding creative ways to make progress in your technology, and also to allow the industry to slowly learn about what you're building, to build a name, to build a reputation, to build your scientific credibility. So we found a way to go around it.
Yeah. Now, you mentioned your service projects with industry partner the Fraunhofer and how it's helped validate your technology. What have those early projects taught you about the real needs of OEM and battery manufacturers?
First of all, it allowed us to see the phenomena. That's the best. People say that image speaks more than 1,000 words, right? So it's really this case. If you see a swelling of a battery and then you analyze it, you measure it, you write a report, but then you say, but you know what, after a week, let's go and see it again. And then you see it even swells even more. That's a very interesting phenomena for the team to see. It's really hands-on. So that was amazing. But I think it's also helped us tremendously to learn about the industry problem, because I remember that about a year ago, I was in a very important conference in Detroit, actually. It was last year. And then I started pitching to the OEMs. I thought we would focus at the time. We thought we were going to make the most impact on the use batteries use case. So I pitched repair and I pitched second life, and I had a lot of examples and they kept on asking me, "That's amazing what you're building. Can you do it on the production line? Can you do it on the production line?" So I think those kind of projects and this kind of talking to OEMs constantly about what we do, but then again, listening to the kind of questions, listening to the use case that they bring to us really helped us focus. And this is why we're starting from the production line. We learn from them where the biggest pain is. So that's constantly a growth process, talking to the customer, potential customers all the time, seeing the kind of problem that they bring to you, but also learning from them where you can help them the most.
Interesting. So I'm hearing that your actual business model changed then in that process.
The beachhead. I think it's really zoning on the beachhead, because we knew all along that we are able to help and do diagnostic along the whole life cycle of the battery pack. So we knew from the beginning that we can help from the production line, and then later when there's a repair or a recall, and then later when we can scan a battery still as part of the vehicle if you buy a used car, and then also in the second life. After the battery is removed, you build a battery energy storage system for a building, and then in recycling. So we intended to really follow along the life cycle of the battery pack and help and add value and add this kind of clarity at every decision point. But I think the conversations with the OEMs really helped us to understand where is the starting point for us. And this is how we really focused on the production line and decided that that's going to be the day one, the beachhead for us.
Yeah, right. So it's also saying like they're experiencing these failures, like you said, at the beginning of the process. And so it's causing them, major pain point there. And as you mentioned, 2 to 5%, up to 5% of batteries are, experiencing these failures, and, which is hard. So if they can identify them when they are, happening on the production line, on the factory floor before they are sent out, that's like the most value to them is what I'm hearing.
Yes.
Yeah. And so it's great that you can also help them in the, remanufacturing of them or the, repair, et cetera, and warranty claims, but they're most concerned about the quality issue at the beginning of the process.
Exactly.
Yeah. So as you move toward production line integration, why are partnerships with factory integrators such a critical part of your go-to-market strategy?
Yeah. The system integrators are the ones that are building the production lines for the OEMs. So this is why the system integrators are the ones that are already partners with the OEMs. So we defined already some time ago that would be the easiest way, the most productive way to get into the production floor. We already established a partnership with a very big and important Korean integrator that we hope to publish really in the coming few days, where we are going to introduce an inline module scanner at the end of the production line, which is a great milestone for us that we're very proud of. Of course, the ability of a system integrator to distribute and to sell is of course, much more advanced than our ability, and it helps us to be able to focus more on the R&D side and on other projects in parallel. So it's really a great strategy for us. So yeah.
Yeah, very exciting. Well, the next few days, we'll have to keep an eye out to see.
Yeah, exactly. Yeah, it's a great way. Of course, in parallel, we are talking to the OEMs as well ourselves. We're talking to the cell producers ourselves. We think it's very important for us to build this direct connection and to learn all the time about the problem, as we did so far. But it's much more effective. You can imagine also there's a production line, there's a conveyor belt, there is a line being built. So if you want to be part of that line, it's much more effective to collaborate with the integrator that's building the line.
That makes sense. Now, as we were talking about, technology is not just about manufacturing quality. It also has implications for resale valuation, remanufacturing, second life applications, and delaying raw material recycling. How do you see battery intelligence reshaping the full life cycle of EV batteries?
Yeah, I think we're standing in all of those topics just before the big wave is coming, because we see there's so many batteries already in the world. Most of them are still new, but later on, the need for repair, repurposing, for all of that is just going to grow. And what we also see is that this is a highly unstandardized industry. We visited and we saw in a few occasions how a workshop for Second Life looks like. And in many cases, it's funny to say, but it's many times a couple of guys with a screwdriver. That's not the way to scale. That's not the kind of standardization that you would expect in this industry. It's not very professional. So we aim to help this industry to standardize, to be the sort of industry 4.0 for this industry, and to set a new standard. That's exactly where we aim to be. And that's the way to make it scalable.
Right. I love that. Yeah. Setting a new standard. It's introducing a product or a process, part of a process that's going to help elevate the standard for batteries in general. And so, Efrat, as more EVs and stationary battery systems enter the market, what role will predictive internal inspection play in preventing safety incidents and extending economic value?
Yeah, it's exactly as I said. It's setting a new standard for better prediction. And we cannot allow incidents like fire incidents that we've seen in urban areas. That's completely preventable. And also, the more we rely on renewable energy, we're going to see more and more battery energy storage systems in office buildings, in urban areas. So the standard of safety needs to be much higher. And exactly as we are already used to doing in the medical world, where we take care of our own health and we are making a huge effort to predict and prevent things before they become a problem, to make sure that our quality of life and health is of the highest standards. That's exactly the same way. And you would never trust a hospital if the doctor tells you, I'm just going to check your temperature and your blood, but I'm not going to use imaging. And you would never trust a hospital like that. So there's no reason for you to not use imaging when it's available to you, high quality imaging, when it's available to you to analyze the phenomena that are happening inside the battery that are unpredictable from the outside.
Right. Yeah. You make a great point. And now that it is available, I think it would be irresponsible really, of companies to not use the technology because of the risks involved. And yeah, definitely. So finally, Efrat, you lead a highly international, multidisciplinary team and clearly love building culture from the ground up. What have you learned about leading people through ambiguity, deep tech complexity, and startup growth?
First of all, I think that the role of a leadership in a startup is to be the most optimistic and positive person in the room. There are so many challenges. There are so many no's or so many walls that you hit. You need to be always inspiring the team to look for other solutions, to never say no, to never accept a failure, to just push through. And we are very lucky to have a great team around us. We're a very strong team of founders, and we built a very strong team of people, young talents around us. We're taking this seriously, and I think we're doing so far a really good job. Also, you mentioned international. I think it's also when people are coming from all over the world, and I think we have at least 10 nationalities between us. What is beautiful is that people find the most common language very, very quickly. So it just builds a very positive atmosphere of collaboration. We also have people that are coming from different disciplines of science, of business, of marketing, and it's just beautiful. And I just love it. I think it's building something from scratch, a new culture, a new business, a new solution is just amazing. It's the best job. It's the best job in the world.
Yeah. So I'm hearing, like you said at the beginning, you're responsible for basically setting the mood, setting the tone, and shaping the culture from the from the top down. And so, are you intentional about creating an international team as well? Is that something that you're looking for in order to shape that culture?
I think so. I think the setting and the atmosphere here around me enables that. The Netherlands, and specifically Eindhoven, where we are based, is the deep tech capital of the area. We have ASML here, which is, of course, a huge magnet of talent and of data. And Philips as well. It's a very deep tech region. So there's talents here from all over the world. Yeah. So really from the Americas, from Asia, from all over Europe. So it's amazing. It's a very, very inspiring culture, inspiring environment, and also a nice balance between men and women, which is also an important thing to have in a deep tech startup. So it's, I think it's really great.
Yeah, that's awesome. That's inspiring. Well, Efrat, thank you for joining me. How can listeners learn more about you and Inner?
So first of all, you're more than welcome to visit our website. That's innertech.ai, and follow us on LinkedIn. We try to post very interesting posts all the time. And feel free, if you think you could be a partner or just want to learn more about what we do, feel free to reach out to me at Efrat at InnerTech. I'm always happy to meet new potential partners or to collaborate.
Awesome. And stay tuned for the next few days for the announcement coming out, right? Yeah. Well, thank you again, Efrat. And thank you to our listeners for tuning in to Industry Ignited. Be sure to subscribe and join us for the next episode. Until next time, stay bold, stay curious, and keep igniting industry.